So here's a series of if, else if, else if, else if, else if kind of logic. So if the number ordered is less than range, then you get that discount. Else if the number of orders is that range, you get that discount. Else if the number of orders is that range, you get that discount. Else you get the last discount. And we did something like that, where we had a low and a medium and a high. So things to watch out for when looking for range checks. Avoid dead or unreachable paths. Don't check for values that can never occur. All right. Requires some prior knowledge of the data. To me, it's a useful idea to check to see if, I'm not sure that I would say don't check for values that would never occur. I might instead specifically check for values that never occur in order to let the user know that that was an invalid value. Never ask a question if there's only one possible outcome. In other words, don't check to see if x is equal to x, because of course x is equal to x. That's just, what were they calling it earlier? A trivial expression. Avoid testing the same range limit multiple times. What would that mean? You could write your code like this, and you wouldn't want to. If you're going to check to see if something's an A or a B or a C or something like that, you know, if score greater than equal to 90, print an A. L if the score is less than 90 and score greater than equal to 80, and so on. We could keep going down, like, you know, all the way down to C, D, E. You know, well, wait, there is no E. Why is there not an E in the grades? Can't ever say I earned an E. All right, anyways, right, like that. Well, I've already made several errors here. You know, for one thing, that probably should be an 80, and that should be a 70. But I'm checking ranges redundantly. I don't need to see if the score is less than 90 because I know that it's less than 90 because it wasn't greater than 90, right? I don't need to check to see if the grade is less than 80 because I know it wasn't greater than or equal to 80. And so this could be cleaned up quite a bit just by removing the things in front of the ands, like this. And it's real easy to see why people would want to code it like this, because you always see grade ranges expressed like this. 90 to 100 is an A, right? 80 to 89 is a B, right? 70 to 79. And so you'd be tempted to code your logic like that, right? But there's no need to. No need to code it with the extra checks if the checks are already handled up here. Just do a clean if, else if, else if, else if, without, because why not do it this way? It might technically be correct, but what if I make a mistake, right? I left a 90 in rather than an 80 somewhere else. Or what if the instructor has changed their grade policies, and to make a B, all you have to do is make a 75. And I change it in one place, but I forget to change it in somewhere else, right? It's making the logic harder to follow, so you wouldn't want to do that. Eliminating dead paths. The items ordered less than range 1, yeah, I'll do something else. Is it greater, less than range 2? Yeah, do something else. Is it less than range 2? Yeah, do something else. Is it greater than range 3? Do something. Well, there's no reason to do it that way because there's no other possible way out. We know that if it's not less than range 3, that it can't be greater than range 3. So you don't even need that if statement here. You just need to give the discount there. So you can combine and ors into a single expression if you want. But you have to be careful. because ands have higher precedence than ors, just like multiplication has higher precedence than addition. So if you have an expression that looks like this, x is equal to 1, y is equal to 2, z is equal to 3, and then if I wrote the expression like this, if x is greater than 0 and y is greater than x, or x is less than z, something like that. We'd have to tear this apart and figure out how it's really going to be evaluated. Ands get done first, just like multiplications get done first. So we would pretend it had parentheses around it. Is x greater than 0? Yeah, it sure is. And so is y greater than x? Yeah, it sure is. So that evaluates to true. And since this is an or, we don't even need to check the last thing over here, right? Because we already know that it's true. One thing or another, if the first part's true, we can ignore the second part, but it also happens to be true. So that would evaluate to true. And I'm not going to take the time to rewrite it in such a way that it would be true if it was evaluated one way and false if we evaluated it the incorrect way. But that's just the idea. Remember to do ands first. Remember to use parentheses if the logic is even a little bit confusing, to make sure that you understand what you're doing and that you're telling the computer exactly what you want it to be doing. If score is greater than min score and score 2 is greater than min score and score 3 is greater than min score, then you print pass. All right, so in that case, all of these conditions have to be true because they're all chained by ands. If score 1 is greater than min score, or score 2 is greater than min score, or score 3 is greater than min score, then pass. So this teacher is nicer. You only have to pass 1 in order to get a passing grade in the class. Because only one of these would be necessary, right? Because we're using ors. Ands are evaluated first. So if age less than 12 or the age is greater than 65 and the rating is G. I don't know what we're trying to figure out here, but if the age, what we probably really want is to put parentheses around this portion of it. Maybe we're figuring out whether to give a discount for the tickets. And so if you're younger than 12 or you're greater than 65 and you're going to see a G-rated movie, since those don't sell tickets, we're going to try to give you a discount on them, something like that. So you use parentheses to correct the logic and force evaluations to happen in the order desired. Mixing and or operators does make the logic more complicated. You can avoid mixing and or by nesting the if statements. So just like we had that business about what your age was and whether what the rating was. Looks like we're on L. So we're going to say that our age, we should be asking the user for the age, right? But instead we're just going to hard code it to some value. And we should ask for the rating of the movie, but just like I said, I'm going to be hard coding everything so that every single time we don't run the program. The way the logic was worded when it was incorrect was this. If age, let me make sure I don't get it incorrect while I'm writing what they have, less than 12 or greater than 65. And so if age is less than or equal to 12 or age is greater than or equal to 65, we're checking outside of the range, so we're using or, and rating equals G, colon, parentheses, quote, discount. Now, for reasons already discussed, that logic is wrong. The only time you would get the discount is if the age was less than 12, or maybe this is correct. Maybe we give discounts only to seniors who are going to see G-rated movies, but we don't care what the other people are seeing. That might be a reasonable assumption if the only people able to see G-rated movies are less than 12. But anyways, what the textbook showed us doing to fix the ambiguity of the logic is I just copied and pasted so that I could put parentheses here like that to make it real clear what I was trying to do. Or I could express it with nested ifs. The movie has to be rated G before we even give any thought to discounts. So we could do if rating is equal to G, colon, and then nest that inside there, the other part. This part right here. How's about I just copy that? Tab that over appropriately. We don't really need the parentheses, although they don't break the expression. Some languages require the parentheses there. I'm going to take them out since Python doesn't. Print, whoops, no caps. Print parentheses discount. All right. So I'm going to comment this one out since it doesn't really work exactly the way we want. The next two do exactly the same thing. So why would you want to do it one way or the other? Well, if you want to print out different error messages or negation messages, the else cases, it might be useful to break it up like that. Or maybe the logic just looks simpler to you like that. Because our brains tend to break down. The computer handles it just fine, right? But if we write it incorrectly because we don't understand it correctly, then the computer's not going to do it correctly. And so looking at this, we're pretty dang sure that that's the logic that we wanted to implement. Whereas up above, the book thinks that we would have some confusion between choosing which one of these two we wanted. So what about that, the book may have had the case, or maybe I'm thinking of the other textbook, where you get a discount if you're a recent grad or if you're employed. Apparently you don't have to be employed if you're a recent grad, and you don't have to be a recent grad if you're employed, and if either one of those things are true, then you get the special discount. So employed equals true with a capital T. Recent underscore grad, that's almost too long, is equal to true. And you could express this logic either with an and or as nested ifs. Let's do it with an and first. If employed equals true and recent underscore grad equals true, colon, print parentheses, quote, discount rate, end quote, in parentheses. Or whatever we're trying to qualify, right? You qualify for the loan, or who cares, right? You qualify. Now, when you compare something to true, you could just leave the word equals true off, right? Because if employed is true, then this evaluates to true. So I could rewrite this to just say if employed and recent grad. I'm going to do that and let you take a look to see which way you like it worded better. So I'm going to copy and paste it. And I'm going to take the equal trues out. These do the same things. Which one do you like better? I like the second better. I would code it that way. If you think it's confusing and in this class you feel like you wanted to code it the first way, that would be also totally okay. But since this equal true would just evaluate to true, if that was the case, then we don't need the equal true. Because this is what's known as a Boolean variable, which can either equal only true or false. And so when we test their cases, that's all we have to do. And I kind of like the way this reads. If employed and recent grad, then print you qualify. But we could have done it as a nested if. If employed, colon, if recent underscore grad, colon, print parentheses, whoops, lowercase d, print parentheses, quote, you qualify, end quote, in parentheses. Like that. Again, why would you pick one over the other? You might want to pick this one if you're going to have else's that print different error messages. This one, the only thing you could print is you must be a recent grad or, right? But I'm not going to add else's. I'm just going to let you sit and see that you could implement these things in both ways, and it's just up to you to pick which way you wanted to do it. And you might be driven, your decision might be driven based on whether you want to put else's or not. I'll show you what I mean up here. I'm going to copy this if rating is equal to if rating is equal to G, the nested if, and I'm going to add some else messages. So else colon print you must be between 12 and 65, end quote, in parentheses. And then for this else, back tabbed all the way against the margin, print parentheses, quote, the movie must be rated G, end quote, in parentheses. Now we could have done the same thing in this first way, but it would just be a single else that would print you must be between 12 and 65 and the movie must be rated G. And maybe that'd be preferable, right? It would give the user all the information, right? Because they might come back to see the G-rated movie and then not be in the correct range, and they would have wished they'd known that in the first place. I don't even know what this is going to do at this point, right? Because we've added a whole bunch of things and we hard-coded the data. We're not asking for any input, so I don't know if it's going to print a whole bunch of messages or just about none. Yeah, whatever. Okay. If we wanted to see it change its behavior, we would change our age to something that was not going to give us a discount, like 25. And it says we must be between 12 and 65. Or what if the movie was not G-rated, it was R? Right? The movie must be rated G. What if we were not recently employed? So I'm going to change that to false. It didn't print anything. We didn't get any error output telling us why we did not qualify. So we may as well fix that. Let's take one of these and add an else clause to it, like this one. Maybe just that one. Else colon print you must be employed and a recent grad, end quote, in parentheses. Now sometimes you don't need an else, right? If something's going to happen, if your hours is greater than 40 and you need to generate a bonus, great. Else, you might not necessarily need to tell them they didn't get a bonus. It may just be okay to not do anything in that case. And I think that's how we coded the logic of that problem that one time. All right, so the movie must be rated G and you must be employed in a recent grad. So I use the term hard-coded. That's when you, instead of asking for input, you just assign a number. And sometimes that's totally legit, right? Because the value of pi is hard-coded, right? You're not going to ask the user for pi, right? That kind of thing. So mixing and and or can make things more complicated. You can nest your if statements to try to make it a little bit clearer. But if you don't think that it's clear, you don't have to do it that way. And then the case structure. Our language does not support the case structure. So I think in order to illustrate the case structure, I'm going to go up and open an interpreter for something that does, like C++ online compiler. I'm just picking one of these at random. Okay, this is a totally different language, but here's what I'm going to do. I'm going to declare a variable called age. I'm going to ask the user for their age. I'm going to let them type it in, which is what CIN means. Cout is the same thing as our print statements, and CIN is the same as our input statements. And then I'm going to do some various things based on the age. I'm not liking this choice, but anyways, let's say that if you're 10, you're going to go to one grade. If you're 11, you're going to go to another. And if you're 12, you're going to go somewhere else. Stupid, but whatever. So switch based on the contents of that age variable. You know what? Yeah. Except this language doesn't use colons like that, so I need to remove that colon. And so in the case of getting a 10, and you don't need the parentheses there, we could see out that we're going to go to Jefferson grade school. Whatever. And then we have to have what's known as a break statement to get us out of that case. And I'm not going to talk about cases and switches too long because our language does not support it. We have to use if statements. But if you're 11, you're going to go to Washington Middle School. And then you're going to break. And if none of the other cases are true, then we're going to see out, I don't know. There we go, right? And then break. So that's a C++ program. The way it works is if they type in some number here, and hopefully they do, switch is just like a switch. You know, you can have off, dim, and bright, you know, tick, 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 or whatever, or the old-fashioned TV selectors where you had multiple dials, you know, channel 3, 4, channel 5, stuff like that. So if they've typed in a 10, it says switch, and if it will go to the 10 if that's what they typed in, it'll print that. Or if they typed in an 11, it'll print that. And if neither one of those other cases are true, then it does that. Now, could you have written this with if-else? Absolutely. There are some forms of logic that you can represent with the case that you can't really do very well with if, and I'm not going to bother trying to come up with one. So if I run it, somewhere on the screen it should be asking me, hello, what's your age? And I'm going to type in 11 just to get the middle school option to come up, right? And so it did. So that's a switch case. I wanted you to see it. Also may be of interest to you just to see what a C++ program looks like. One of the things to note about it is that in C++ everything has to be in a function. Everything has to be in a module, except they're exclusively called functions in that programming language. Nobody uses the term modules like our textbook does. So there's a main function here that all of our code had to be in, or else C++ wouldn't even know where to start. If we didn't have that word int main there, it wouldn't run. Another thing to note about C++ is your variables have to be defined. Right? We had to declare that variable, and we had to specify its data type. Once we've declared this to be an int, we can't store a floating point number in there. We couldn't say that our age is 11.3. Or we couldn't say that our age is, quote, 12, end quote, right? It has to be a number. It has to be a whole number. So you declare what type your variables are, and then that variable is known to the compiler to be of that type and only of that type, which makes the compiler able to write more efficient code that'll run more quickly. What do I mean by compiler? When the program needs to be run, it has to be turned into machine language, right? A computer has no idea what cout hello world means. But once it's compiled and the machine language is all generated, the machine language can tell it just fine. You know, okay, please display on the monitor this message. And please let the user type in keystrokes, right? It handles all that so that we don't have to do all that incredibly complex stuff. We can just write statements like input and print, or cout and cin. So that is the case structure, used when there are several distinct possible values for a single variable. And each value requires a different subsequent action. Here's how they show a flow charting of it. And I'm not going to ever flow chart it because it's not in our language. But like switch based on the year. Year 1, your tuition is that. Year 2, your tuition drops. Wouldn't that be nice? Year 3, your tuition drops again. And year 4, your tuition drops even a little bit more. Right? Looks a little bit different, right? Otherwise, you'd have to write it like if, else if, else if, else if, else if, in order to get that to work. Certainly makes for a cleaner looking flow chart, even if the code looked a little bit more confusing. I hope it didn't, though. I hope the code made sense, even though it was written in the language we're not using. So the summary. Decisions involving Boolean expressions. Boolean expressions are things that evaluate to true or false. X less than 3. You use relational operators to compare values. If X equals 7. If age less than 12. If the temperature is less than 32 degrees or temperature greater than 212. That kind of thing. You know what an and is by now, just because you know the English language. It means both sides have to be true. For efficiency's sake, in an and decision, if you're trying to write things that run more quickly, then the first part of it, the first so-called operand, the first clause before the and, should be the one that's least likely to be true. Because if it's true, the rest of the expression can be ignored. An or decision requires one or the other one to be true. They don't both have to be true. And so for an or decision, for efficiency's sake, you ask the question first that is more likely to be true. Because if that one is true, it can skip the rest. So for a range check, if you're checking inside the range, you use and. If x greater than 2 and x less than 4, then you know it has to be between 2 and 4. But I kind of made a mistake because I probably would have needed to use greater than or equal to 2 and less than or equal to 4. Otherwise, the only number that would be between those two would be 3, unless we're allowing decimal values, right? And does take precedence over or, just like if you have 3 times 4 plus 2 times 6. You have to do the multiplications first before you do the adding. You don't do 3 times 4 is 12. Plus 2 makes it 14 times 6. That'd be completely wrong. Instead, you get 3 times 4, which is 12, plus 2 times 6, which is also 12, and then you add them together to get 24. Same business with or. I'm not going to write a great big and and or. Same business, though. If you had A and B or C and D, these expression would be evaluated first. Then that expression would be evaluated first. And if either one of these had evaluated to true, then the whole thing would be true because that's when the or would happen. And the case structure, we talked about it, specialized structure, where you list all the several distinct possible values. The only problem with the case structure is that in some ways it's not as flexible as ifs are. Why do I say that? What if I wanted to write something that said grades 1 through 6 are elementary? I would have to do case 1, colon, case 2, colon, case 3, colon, case 4, colon, case 5, colon, and case 6. That'd be really annoying. Let me change this to be a little bit more accurate, right? Case 1, case 2, case 3, case 4, case 5, case 6. All of those should say Jefferson High School. Excuse me, grade school, or elementary school. And maybe that looks cool. Maybe we like the way that looks. But on the other hand, we could have just written if grade greater than equal to 1 and grade less than equal to 6, right? That might have been a nicer way to do it. All of those cases would now do that. So what if there were 100 different choices that went there? It would be real tedious to put cases 1 through 100. So there are times when it doesn't make sense to use switch case, when you just want to use if-else. It's just dependent upon the use and which code makes the code look cleaner. What do I mean by cleaner? If you're looking at the code and it's easier to understand instantly by looking at it one way as opposed to the other, that's cleaner code, right? It's easier to understand at a moment's notice, and that means that it's less likely that it has errors in it, or that if it does, you can fix it. Something else to notice about the C++ language is that indentation is not necessary. Even though this makes it look like, that I'm following pretty good indentation rules, I'm really not. All the textbooks that I've used would want it to be indented like this. In Python, you know that an indentation error can totally break the code. In this language, no, not at all. If I felt like it, I could get rid of indentations altogether. I could just totally mess it up, right? It'll still run just as well because it uses the curly braces to mark the blocks of code rather than the levels of indentation. Python just kind of enforces the indentation instead of using the curly braces, and it makes the logic hopefully cleaner because it doesn't let you write stuff like this. It doesn't force you to write clean code, cleanly formatted code. And that's the end of chapter 4. So let me go check. So, chapter 5, looping. We've already done looping a little bit. So we can just say we're done with it. Nah, let's actually look through it a little bit. The advantages of looping: using a loop control variable, nested loops, avoiding common loop mistakes, etc. Let's not just skip let's not read every objective. Looping is what computers are all about. If you were playing a game and it got input from your joystick to make your character go left, if your character went left and then the game ended, that wouldn't be very fun. You'd want it to keep checking the position of your joystick and keep tracking where your character is. In these programs where we calculate the pay or whatever, once you type in your numbers and you're done, like what if it had printed a paycheck then? It'd be really annoying if you had to rerun the program again to print out somebody else's paycheck. It'd be cooler if it just kept doing that over and over and over until you were ready to be done. Or that guessing game, right? You get one shot at it, pick a number between 1 and 100, you type in 65 and it says, ha ha, you lose, and that's it. Now that wouldn't be any fun, right? And so looping is pretty much what computers are all about. If you get the idea of if logic, if you get the idea of looping, and you get the idea of function calls, then you're going to walk out of here a programmer. And you are going to get all that stuff. So why do you write a loop? So that you can write one set of instructions that work on multiple sets of data. Let's do an example of that. Let's come up with some cool little equation that calculates one thing based on another. We're going to print out the pressure at various temperatures. And so we're going to have a couple of things here. We're just going to say a volume of 22.4, and I made a capital V, and I don't know why, so I'm going to make that close, lowercase. And I'm going to use something called the ideal gas law, and you absolutely don't have to know what an ideal gas law is in order to understand this example. So n equals 22.4, V equals 22.4, n is equal to 1, R is equal to 0.0821, and V is equal to 1. Now we're going to write an equation that calculates something. The last piece of information we need to know oh, I have already had a V. Forget that. Sorry, get rid of that. But we do need a temperature. And room temperature might be, we're talking about Kelvin now. And so let's say 70 degrees Fahrenheit in Kelvin. Kelvin is an alternate thermometer system that measures only from absolute zero. You can't get lower than absolute zero, and that's a complete lack of energy in the substance. So rather than being able to go negative. So anyways, we're going to say that 295 is room temperature. So our T is 295. And here's what our equation looks like. P, which stands for pressure, measured in atmospheres. Right now we're at about 1 atmosphere, right? Because we can have 1 atmosphere above us, right? But if you went up, halfway into space, the atmosphere pressure might be half, 0.5 atmospheres, whatever. So is equal to N times R times T times V. That's the ideal gas law. No, it's not, because we have to divide by V. My mistake. N times R times T. Okay. So say I wanted to do this for a range of temperatures. I wanted to do it for 295 up to 305. Well, let's print out our temperature. So print, parentheses, quote, at, end quote, comma, T, comma, quote, Kelvin. It'd be cooler if we let them type in the temperature in Fahrenheit and then we had a function that would convert it, comma, the pressure is, end quote, comma, P. That's enough. All right, but I wanted to run this 10 times for 295 to 395. Excuse me, to 305. That's actually 11 times. Well, here's what I'm going to do. I'm going to copy and paste that once, twice, three. By the time you start copying and pasting, you know that you should have written it as a loop, right? So this has got a lot of repeated code. The only difference in the repeated code, let's just stop there, right? There's no reason to belabor the point. The only thing changing in the repeated code is the value of the temperature. The equation is the same every time. The print statement is the same every time. So this is kind of what's called brute force programming. There's no loop involved. You're just copying and pasting, because you're desperate to get the problem done as fast as possible. Whatever. What if there was an error in the equation? I would have to fix it, 5, 6, 100 times, however many times I'd copied and pasted it. This would not be a good idea. All right. And so at 295, the pressure is that. And as the temperature increases, the pressure of the air increases. And that's true. If you stick a balloon in the fridge, it shrinks because it gets cold, so the gas contracts. Anyways, would have been far better to write that as a loop. So let's do so. Let's pick the rest of it up, going from 300 to like 310 with a loop. So for T in range, starting at 300 and going up to 310, so I actually need to make it 311. That sounds counterintuitive, but it starts at 300, but it stops when it gets to 311, meaning that it's only going to count the numbers 300 through 310. It's just like it said T less than 311. Think of it like that. Not less than or equal to 311, less than 311. So there it is. 300, 311, 1. Go up by 1 each time. Because you could go up by 2 each time, right? Or 12 each time, or -1 each time, or something like that. And then in parentheses, colon, and then take these two statements, copy them, paste them, and tab them over one so that they are indented, so that they are the body of the loop. Like that. Now this is going to handle all 10 cases, just in 3 lines of code, whereas we had, I don't know, to get those 5 temperature calculations, we had 15 lines of code. That was really dumb. This is nice, clean, and efficient, right? If we had to make a change to the equation to get it to work, it'd be real easy. We would just have to fix it in one place. If we wanted to add the word atmospheres to our print statement to make it look, display all the units so that somebody doesn't wonder what the units are. 1 what, right? Anyways, let's go ahead and run this, and we will see it finish off our little program in style, right? There it goes. The loop was a way better way to implement that. I hope you agree. In the Kelvin scale, it's 293. Boiling is 393, roughly. And let's just go up by 10 each time so that we don't see 100 different temperatures. We'll see only 10 temperatures. And there we go, right? The pressure increased quite a bit. It almost increased by 50% from there to there. That almost seems too much. If you're outside, although I guess that explains why the balloon shrinks so much, right? Although it doesn't start off at boiling temperature, right? We never go outside and find out that it's, 212 degrees outside. Instead, what did we decide that room temperature was? About 295? Oh, that's not right. I better go and check. What is 32 degrees F in Kelvin? 273. Okay. So, I made an error in my loop. Why don't we fix that? Started at 273. My mistake. But we're going to see a big difference now. At the freezing point of water, oh, no wonder I was looking way up here. But anyways, at the freezing point of water at 273, the pressure is about exactly 1. And by the time it boils, the temperature is much higher. That's the way a hot air balloon works, right? You heat that air to super hot, it causes the air inside the balloon to expand. And it's not just that hot air rises, it means that hot air has less volume, and things that have less density float, which is why ice floats on water, right? It occupies more space for the same amount of weight. We don't care. We're not physics majors, most of us. Anyways, so we have written a loop, and that we kind of proved the efficiency of it by being able to radically change the conditions and just run it within seconds. Whereas if we had copied and pasted it, we'd have to change, all of these specific variables. One limit in this language that I don't particularly like is that the for loop in this language does not allow decimals. It has to be integers. I can't say I want to see all the temperatures from 273 to 273.5, raising by 0.1 each time. Don't do that typing because I'm going to have to undo it immediately. It's just going to give me a syntax error. You can't use decimal points. You can't use floating point numbers for a range statement in this language, unlike some languages. In fact, most languages have a for that'll work on floating point just as well as integers. Yeah, well. So the first number is the starting point. The last number is 1 past the end point. So this goes from 273 up, wait a minute, 273 to 273. Make that 373. So that goes from 273 up to 372. And so if I really actually wanted it to do 100, I should make this 1 more. Right, because I wanted it to go to 273 to 373. And it's that 1 more bit that gets people messed up just a little bit. If you leave the first number off, it defaults to being 0. So if I did this, for x in range 10, in parentheses 10, in parentheses colon, and then I print x, it's going to print 0 through 9. So if you leave the first argument out, it defaults to 0. So if you don't want it to start accounting at 0, you better specify it. For x in range 1, 11, colon, print parentheses x, that would print 1 through 10. And if you put one more number there, so I'm just going to copy and paste this one and make it count by 2's. For x in range 1, 11, going by 2's. I don't want that. I want it to go 2, 4, 6, 8, 10. So I'm going to start it off at 2. So this is 2 through 10 by 2's. What if you want to go negative? You just make that last number negative. You want to count 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff? You could do that. I'm just going to print a blank line because so far all of this stuff will have been just an uninterrupted stream of numbers, right? So why don't we put a blank line there? And then let's do one that'll count down like a rocket. For x in range, I want it to start at 10, and I want it to hit 1, so I got to go 1 past 1. It works the same way going negative as positive. So 10, 0, -1 in parentheses. This counts 10 to 1 by -1. And so let's print parentheses x, quote, dot, 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 right? Like there's a pregnant pause there. And we could even make it wait a second, which is called a sleep command. And I know that you looked up the syntax of the sleep command like on the first day we were here. That's when I knew you already knew a lot about this stuff. So Python sleep. Do we even have to include a library to get it to work? Yes, we do. So to get this sleep to work, we're going to need to import something, just like when we imported the turtle to draw some cool stuff. So here, do from time import sleep. So from the time library, import the sleep command. Why? So that we can sleep a second. Sleep, and I believe it's in milliseconds. So I think we're going to have to type 1,000 to get it to sleep 1 second. And then I'm going to back tab so that it only prints liftoff once. Because if I did this, if I did print parentheses liftoff right there, it's going to print liftoff 10 times. I don't want it to say 10 liftoff, 9 liftoff, 8. So I want this outside the loop, after the loop is completed, not in the body of the loop. And so here it's starting to count down. 10. All right, that's more than a second. Maybe it's actually measured in seconds. Maybe it's I told it to wait 1,000 seconds. Let's change that to just sleep 1. Yeah, that looks right. There we go. Why do bombs on TV shows always have great big red LED countdowns? I don't know if I'd want to make it draw attention to itself in that fashion. Well, whatever. So there we go. What if we wanted to do the same loop, but not with a for loop? Anything you write with a for loop, if you went to the trouble, you could do a while loop. Now the book shows us while loops first before they show us for loops, but we've already used while loops, so that's why I kind of fast forwarded to this. But let's start x at 10. X is equal to 10. While x is greater than or equal to 1, colon, or I could just make it while x greater than 0, and then it would kind of have that 0 there just like that one did. But when I'm writing a while loop, I'd rather do greater than or equal. That suits my mind a little bit better. Print, parentheses, quote, again, x comma, quote, dot, 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 end quote. Wait, that's looking pretty weird. Get rid of that beginning quote. It needs to be black, not green. So x comma, quote, dot, 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 end quote, in parentheses. Let's have our sleep again. I should have just done some judicious copy and pasting. Sleep 1 in parentheses. Now I'm going to make a deliberate mistake. Print liftoff. So just be warned that I've made a mistake that we're going to have to correct. So 10, 9, 8 is going to count down to liftoff, and then it's going to start over at 10. All right, we have a bug, right? Our poor rocket, never going to get off the launch pad. What do I need to do to make it count down? I need to change the value of x. I need to modify the loop control variable. If we want to talk in more computer programmerese, this is the loop control variable because it controls the loop. And if the loop control variable never changes, then it's just going to keep doing the same thing endlessly. Kind of like the instructions for shampoo: wash, rinse, repeat. A programmer would die in the bathtub trying to wash their hair that many times, right? Or until they used up the bottle. There ought to be a condition expressed. While hair is dirty, wash, rinse, repeat, right? So anyways, let's do x minus equals 1. Or if you like to write it out in long form, you could say x equals x minus 1. Can't put a space between a minus and an equal in this case. That's just one symbol. But I think I'm going to write it out in the long form this time. X equals x minus 1. Now it's going to work perfectly. I hope. I say with perhaps false confidence. Let's run it. You know what, maybe rocket should start at 5. It's taken a long time to get this thing in the air. And our second loop is working as well. So we didn't have to use a for loop. But for loops are so easy to write for their purpose, which is to go over a sequence of values, right? What did we have to do if we weren't going to write it as a for loop? We had to initialize our loop control variable, and then we had to have the condition, and then I had to remember to have the update, and that took 3 lines of code where that was all expressed in this statement. It declared the loop control variable x, it set the starting point, it set the end point so it knows the condition, and it has the update all in one line. So for loops are great when you're going over a set series of values. Getting close to stopping, but let's make a note of that. For loops are perfect for so-called definite loops, which count over a predictable range. The fancy word for count would be iterate. A specific series of values. While loops run until a condition becomes false. Just like our guessing game, right? It stops when our guess is correct. So as soon as the condition becomes false or it hits a break statement, which we haven't talked about, but I guess we could insert into our while loop up there. So while loops run until a condition becomes false or a break statement is executed. Let's show a break statement. Let's say that we have some guy in mission control who gets bored waiting for this rocket to go off. So as soon as X hits 5, we break. If x equals, I'm going to delete this line by the way. If x equals 5 colon break. So now it's just going to count 10, 9, 8, 7, 6 because as soon as it hits 5, it's going to break out of the loop. It's going to leave it early. I should speed that up so it's like a half second. Right, we count more quickly. But anyways, so this time it's not going to get down to 1 before it says lift off. Right, there we go. Right, we launched early because of the break statement. So the while loop continued until this condition became false or until we hit the break. Now it's silly to get out early, so I'm going to delete that. I just wanted you to see a break statement. All right. So we're going to do some homework based on these concepts. It's not going to be real rigorous. You already have all the information you need based on what we've done up here so far. So it might only take you a few minutes. And I think that's okay because that means you understand it. If it takes you more than a few minutes, that's okay as well. Just text me for help. So write a for loop that will count and print the numbers 1 through 29. Then write a for loop that will count and print the numbers 30 through 100 by tens, right? Plus equals 10. Or no, don't do plus equals 10, but you know how to add that clause to it. It's that third number. We did an example of that where we counted by 2s right here. So just take careful note of that one, except you're going to make your third number 10. And then lastly, write a loop that counts down from 99 to 90 by -1. So it's just going to go from 1 to 29, and then it gets impatient and goes from 30 to 100, skipping 10 every time. And then for whatever random reason, we want it to start counting back down to 90. So 3 for loops. Some people like to do their homework even before they walk out of class. That one I bet you could do. All right, I'm going to step away from this so that I can get the Dropbox made for y'all.